Okay, I'm going to try and explain this one on the fly. I'm going to take my time. I don't want to rush myself. I've been rushing myself recently. So the question is, show by drawing the three medians of a triangle. We divide the triangle into 6 regions of equal area. 1, 2, 3, 4, 5, 6, of course. If you didn't know, a median is the line that joins one vertex to the midpoint of the opposite side. So these are equal, these two lengths. So first, I think we have to start by showing that any one median divides the triangle into two triangles of which their area are equal. Two triangles of equal area. So let's consider the median AD. This divides the triangle into ACD and ABD, where CD is equal to DB. Now these two triangles share the altitude from A. Now there's quite a simple theorem. If two triangles share the same altitude, then the ratio of their areas is equal to the ratio of their bases from which the altitude goes to. Now the ratio of these bases is 1 to 1 as they're equal. That means the ratio of their area is 1 to 1, i.e. the areas are equal. So if you don't see why that theorem's true, if I call, let me get rid of these lines. If I call the area of the left triangle A2, the area of the right triangle A1 and A2, and I draw the altitude. So A1 is a half CD times the height H. Now what's A2? A2 is half the base from here to here, and the altitude from A to the extension of this side is also H. So it's that as well. Okay, let me rub this all out. So what do we know? We know that one median splits the triangle into two triangles of equal area. So what else do we know about medians? We know that the centroid G divides a median into the ratio 2 to 1. I think I'll use that altitude argument again and this ratio to perhaps show that this triangle is a third of this triangle made of 3 triangles. So how can I do that? 2 to 1. Alright, I think I see something here. So, or do I? What do I see? 2 to 1. Two to 1. Do any of my 3 triangles have this altitude? No, they don't. I see. If I extend this and think about this altitude. This is the altitude of both triangles FGB and the larger triangle FCB. Okay, I like it. Okay, so, and the ratio of the side lengths of the side to which this altitude goes to is 1 to 3. As a larger triangle is 3, small triangle is 1. That means the ratio of their areas is also 1 to 3. So this is a third of the area of FCB. Okay. Now what? It's easy to see that this triangle and this triangle have equal areas because they share this altitude and they of course have the same base. But how do I show that? Well, yeah, I guess that does say that is a third because the area of this larger triangle is 2/3 of FCB, and these are equal, so they must both equal a third of FCB. 1/3, 1/3. That's 1/3 of FCB. So these are all, and as FCB is a half of ABC, that means all of these are 1/6 because they're a third of a half. So they're 1/6, 1/6 of the total area, 1/6. Now, what about this side? Well, by symmetry, it's just the exact same argument. So, to get the first one, well, these two are equal by that same easy altitude base argument. So those two are equal. And we know ACF is a half of the total triangle, and these are equal. Let's just say that. Now, what about this one? If we can show this as well, we've already done it. I'm just I know it's already true by symmetry, but I'm gonna try it. I'm just gonna do it anyway. Don't know why, but just to get some practice explaining things. So AGF shares this altitude with ACF, and the ratio of their bases is 1 to 3, so the ratio of their areas is 1 to 3. So AGF is a third of the area of ACF, which means it's a sixth of the area of ABC. 1/6. Again, this is a third of ACF. I'll call it AFC. This is a third of AFC. So these two combined are 2/3 of AFC, but they're equal. So each one is a third of AFC, i.e. a sixth of ABC. So there you go. The three medians divide the triangle into 6 regions of equal area.